So back when I initially started working with MoMA, and at the time, the media conservator was Gillean, and we started with really the need to articulate what the business case was. The question was not like, oh, we need a technology, we need a tool, we need a solution. It was, we have challenges and we need to find ways of dealing with them. We need to find ways to automate the management of an increasingly complex and growing digital fine art collection, or fine art and architecture design collection, actually. So what this slide shows, and I hope you guys can see over my head, is that the upper left-hand corner sort of shows a growth rate of gigabytes, and it says, you see it's showing back to the 70s. What that actually represents is the acquisition date of a work that was likely subsequently digitized, and so the resulting data of that artwork, the artworks acquired in that year equal the graph. So, and then you can see there's a spike in acquisitions in 2010, 2011, and you can imagine the trend only increasing from there with the advent of HD video and such things. So at the same time as a lot of these videos are being acquired and digitized from analog sources, there was also the increase of complex software-based artworks. You can see an example here, which is Jonathan Harris and Seth Camber's I Want You to Want Me, which is data-driven, interactive piece. So there was a lot of this increasingly large amounts of data and more complex data coming in. Conservators were struggling with the, their task of automating the conservation, the long-term preservation management of these works. So, what do we do? So, over this time, I just jumped from 2008, and that was a long stretch of saying we did a lot of business case development, articulating to the management of the museum the need for a new way of approaching digital collections conservation. And so they said, that's great, we're on board. Why don't you tell us what you think it should look like? And as Ben mentioned, we did draw a lot from the existing community, the digital preservation community that had already started to build up, but was not as active in the museum's context yet. So in mid-2011, we started to actually develop a sort of system specification. What we did first was, this is the type of process that kind of everybody goes through or should go through when we're starting to look at adapting or building solutions for our problems related to digital collections management. So we wanted to get all the stakeholders involved who were really critical to the conservation, the use, and the curation of digital collections. So we started out with conversations with 5 different departments and a total of 13 interviewees to start to understand their needs and goals and their use cases. So the next task was to take those use cases and to specify them out, detail out what the users actually need to do here and that they can't do now. And from there also articulate a set of requirements for our specification. So we ended up with 55 functional requirements at a high-ish level, and 22 use cases that illustrated the user's interaction that would show that functionality in practice. And those ranged from everything from SIP creation and ingest to fixity checking, reporting and administration. So the whole gamut of basically digital preservation activity. From there, we kind of came up with a specification document, and we wanted to get input from practitioners in the field who were very experienced with this type of work, and see what they thought. So we had an experts meeting back in early 2012, something like that, with 6 external advisors and a couple of people in the room today. Stephen Amos from California Digital Library. We got Howard Besser from NYU MEAP. I don't know if Howard's in the room. And Hannah Frost at Stanford Digital Library, Jerome McDonough from the University of Illinois, and Dan Millman at NYU. And we also had Ben Fino-Radin, who was then at Rhizome at the New Museum. And so that was actually a very serendipitous and fortuitous meeting that Ben was able to participate at that time, because you see here now that he's become instrumental to driving this project forward and seeing it to fruition. So the specifications for the DRMC were released internally in mid-2012, and it was during the next year or so that a lot of work started to happen to fulfill the requirements that were laid out. We kind of started with 2 bookend systems, TMS, which is the collections management system used at the museum, and the DAM, which was used for access to images, digital images of artworks. We knew those things sort of had a role to play, but we didn't actually know what they were. So now that we had a system specification, we could kind of look at those systems to see whether they fulfilled our requirements or not. Turned out they really didn't. So what we needed was sort of storage. We needed conservation storage. We needed services that would allow us some preservation, kind of ingest processing and things like that. We needed database and applications to help manage the collection as well. So during this time period, we started to fulfill some of these boxes. The storage system was acquired and dedicated to conservation storage. We had the addition of a digital repository manager, which is Ben, and so that has been extremely important, as I mentioned. And then we also saw the introduction of Archivematica. It was a solution that was available, an open source solution that could fulfill so much of those needs around the services that we had articulated. So now that we had all this stuff in place, we were just missing this one piece, which sort of became like a piece that went together. It's this access and data management layer. And so what we did from there was, in mid-2013, is refactored our requirement specification specifically for the management application layer. And so for this, we issued an RFP, which had 32 functional requirements and 9 use cases that were all about user interface management, reporting, but other things like fixity checking and things like that. So, and I will turn it back over to Ben, who's going to talk about the RFP and vendor selection process, which began in April of 2013.
So the DRMC RFP was sent to 5 software firms, which we identified as potential candidates through conversations with peer institutions, also talking internally to our director of applications, our creative director, as well as just personal friends working in more of the startup and tech sector. Of the 5 firms we sent the RFP to, only 3 of them made it to the final assessment round. These 3 firms represented a very wide variety, actually, and each was drastically different from one another in every way, from size, domain expertise, client base, and experience. For the sake of this presentation, we will refer to these 3 firms as the large vendor, the small vendor, and the very small vendor. So the very small vendor and the small vendor had similar total staff sizes of 17 and 36 respectively. I guess not that similar, about double from one to the other. While the large vendor had a team of thousands and offshore teams, and each firm, however, proposed DRMC project teams of similar sizes, around 5 to 7 people dedicated to our project. So the RFP process was really designed to provide an example of the quality of product, of course, that we could expect from given applicants, but also to really just reveal the personality and the character of the firm. The deliverable review and feedback process that we asked for in the RFP served to provide us with a glimpse of what it would be like to work with a given vendor, what our working relationship would actually be. This process revealed some very alluring qualities in the large vendor. Their project management and communication skills were quite unparalleled, and due to their size, they did have the ability to scale the project team on demand if need be. What they lacked, however, was domain expertise. And they had not worked extensively in preservation or archive-related capacities. This was a distinct difference from the small vendor and the very small vendor, who had both worked quite extensively in the digital preservation domain. At the end of the day, this domain expertise was found to be one of the most critical characteristics. Superior communication and project management, of course, is a must. However, if a vendor has not worked in the digital preservation field, half of said communication will be solely about establishing common ground and mutual understanding about more edge terms. The 2 smaller vendors were able to sit down with us and really point to where our specs fell short. Due to their expertise, they were able to, in the end, offer us the option of excelling beyond our stated goal, which admittedly was vague. As I'm sure you have surmised at this point, the very small vendor was indeed Artifactual Systems, the makers of Archivematica and access to memory. So MOBA's internal DRMC team steering committee was, to be quite frank, initially, at least on paper, quite skeptical of architectural systems. In addition to being drastically smaller and younger than the other two contenders, they weren't a general purpose vendor. Rather than holding a diverse portfolio of work that they had produced for clients over the years, Artifactual existed for the sole purpose of their two core products, Archivematica and Atom. It warrants mentioning that this is something that was very different from what a large institution such as MoMA is used to working with. Of course, recently we've moved more towards agile methodologies and program pairing, where we actually have MoMA developers and residents at Pivotal Labs who are building things for us. But historically, we're used to working with much larger vendors, which, when you're a big institution, has a certain comfort and stability to it. So this was very new ground. So despite that skepticism, after Artifactual's on-site pitch to our team, everyone was essentially unanimous. We were all incredibly impressed not only with Artifactual's passion and intellect, but also the degree to which we realized that what we wanted to build was completely a direct extension of their years of work and an opportunity to collaborate, to realize some digital preservation ideas and concepts that both we and they were passionate about. As we stated earlier, it had become simply crystal clear that due to the complexity of our project and our requirements in its niche domain, that it would be a major benefit to work with a team comprised of experts in this domain. A good software vendor simply wasn't enough. We needed a good software vendor with a team consisting of domain experts. There were latent pitfalls and roadblocks yet to be discovered, which general software engineers wouldn't be able to help us past. Simply building to spec wasn't an option. It was in this light that we realized Artifactual Systems was the clear choice, and as a small and nimble team of information scientists, archivists, and developers, they were simply uniquely positioned. And so began the hopefully long-lasting relationship between the very big institution and the very small vendor. And I will now turn things over to Dan Gillean, who has been managing the DRMC project over at Artifactual.
So, as Ben and Kara have outlined, a lot of thought went into MoMA's selection process, and I think the seriousness and engagement that they showed in even these initial steps is one of the things that really made us want to work with them. There were many firsts in this project for Artifactual, and the Agile development model was one of them. But as a company, we're most known in the US here for our work with Archivematica, but we also develop and maintain an open source web-based description and access application called Atom, or Access to Memory, which I'll be mentioning more in relation to this project in a moment. We have a skilled and passionate team at Artifactual, and our experience in developing Archivematica and Atom served us well during this project. Currently, we're a company of 17 people, and we had about 7 people focused on this project throughout, with contributions from other team members throughout at various points. So, one of the original strengths of our proposal to MoMA was in pointing out that many of MoMA's requirements for the DRMC were already covered by existing Atom functionality. Consequently, our original plan was to develop a DRMC as an extension of Atom. However, we also wanted to ensure that the DRMC would be viable in the long term, regardless of what happened to Atom, without losing the advantages of reusing some of the existing functionality in the short term. As such, what we decided to do was abstract all the DRMC code from Atom and use Atom as a sort of back-end dependency that can eventually be improved or swapped out in the future with minimal effort. For those interested in the technical details, we're using a MySQL database for storage, Elasticsearch as our index, and we used AngularJS and Twitter Bootstrap for the front end. D3 is the library that we used in the context browser, which is a feature you'll see in the demonstration in just a bit. So I'm going to talk a bit about the development methodology that we followed throughout. One of MoMA's requirements in the RFP was that an agile methodology be used for development. Agile is focused on iterative and incremental development, where short-term goals and concrete deliverables are regularly set before the client for review, and then the review process informs the next phase of development. At the same time, we wanted to be certain that by the time we began development, we had a solid vision of the application in place. In the end, the approach we followed involved 2 main phases, planning and development. Phase 1, the planning phase, was broken into 2 parts. from July to September of 2013, we focused exclusively on analysis and design, followed by a site visit in September to review the initial planning. From October to December, we created a prototype to assess if our initial planning would translate well when moved from paper to the screen. Phase 2, the active development of the application, was scheduled between January and June of 2014. Following the Agile methodology, we then broke Phase 2 into 5 main development sprints with about 6 core deliverables in each sprint. Based on what we knew our small team could handle, each of these sprints were scheduled to be executable in about 300 hours per sprint. Additionally, we held weekly project review meetings internally at Artifactual, and David Uhas, our project manager for the DRMC, prepared bi-weekly progress reports for Ben, which were followed by discussions via telephone. So if there's one important takeaway that I can share from this process, it's this. If you want the final deliverable to go simply beyond meeting your most basic requirements in the most minimal way possible, you need to expect to be deeply involved in the process. MoMA understood this from the outset. It's one of the reasons they insisted upon an agile development methodology when issuing the RFP. So you can't really read any of this, but what this is showing here is the comments on one of our development tickets in our issue tracking system. And the most important thing is to see how interactive it is here. Beyond just daily discussion between the developers, there was regular participation and input from Ben. No matter the vendor, there's simply no way you're going to be able to hand off a set of requirements and expect to receive an ideal solution returned to you at the end without involving yourself in the process. Many of the things that seemed ideal on paper in our workflows and wireframes, it simply didn't work as expected when finally sitting a user in front of the screen for the first time. The Agile approach assumes this from the outset and makes allowances for the app to evolve through the development process. So I'm just going to walk you quickly through an example of this from end to end. The image on the left depicts one of the use cases that MoMA had outlined as a requirement for DRMC functionality. In essence, the conservator searches for a work, finds it, navigates to it, and then browses the files contained within an associated AIP. First thing we did in Phase 1A was to take these text-based use cases and transform them into workflows, shown on the right. Based on these workflows, we could then determine how many wireframes we felt would be necessary to illustrate the interface as each action took place. On the right, you can see the wireframe we produced of the interface as the user searches for a particular artwork record. These wireframes were then used as the basis for development. On the right is the application as it was about 2 months ago. Many elements have been developed almost exactly as they were in the original wireframe, while other elements have changed based on the flexibility of the Agile model: testing, feedback, evolution. In addition to this development methodology, MoMA made sure to invite feedback from the broader community at key points in the development timeline. This helped ground all development in concrete feedback and ensure that other stakeholders outside of MoMA's specific use case were advising us on architecture, usability, and design. These include an experts meeting in December of 2013 who conducted a suite of usability tests, and a technical advisors meeting in March of this year to request further inputs from experts within the digital preservation community. Further usability testing was also conducted in April of 2014. In all, these sessions have provided invaluable insight for both Artifactual and MoMA. They've helped to produce a much stronger final product thanks to the wisdom and experience of this broader community of experts. However, there are always going to be unforeseen challenges when you sit a user in front of the software for the first time. It's important to remember the complexity of the problems we were trying to solve with MoMA and developing with DRMC. To our knowledge, there's not really any other software currently available that aims to meet these specific needs. Archivematic's storage service, along with many other existing repository software applications, will allow you to store and interact with your AIPs, but there hasn't yet been much discussion around how to manage the complex relationships between related AIPs, the supporting technologies required to preserve and display them, and the artwork components to which they relate. The DRMC also aims to offer user-friendly reporting, at-a-glance statistics via widget-based dashboard, integrity checking of preserved objects, save searches, faceted results, and more, all via an intuitive graphical user interface. As we move forward in our development, we learn to be much better about avoiding scope creep. Part of this is an understanding that building a new application is much different than developing a new feature for an existing one. It's important to understand that the first phase of development is about the architecture, the building blocks, the moving pieces. Refinement and perfection can always come later. As such, I think MoMA learned to be much better about accepting minimal viable product as the deliverable in this first phase, and we began discussing the possibility of a second phase of development, where these finer-grained details could be attended to once the initial architecture was in place. We all learned to keep the focus on the big picture and see development as an iterative process, even beyond the second phase. So I'm about to turn the floor back over to Ben so we can actually see the software in action. But before I did, I thought it'd be interesting to just show you one of the original wireframes that came from our RFP, just so you can see how far things have changed. So this was included in the RFP response. It depicts a user browsing AIPs associated with a particular artwork. And here's a shot of the software as it looks currently. I think that this comparison in many ways is the strongest argument for how useful this model has been for all of us. While the first wireframe, had it been developed, would have met the original use case that MoMA had presented, I think what we finally developed is a far more intuitive, visual, flexible, and useful interface. We might never have arrived at this solution without the flexibility of the approach that we pursued. So, shall we take a look at how things actually look?
All right, so the moment you've all actually come here for, show it to us. Okay, so you'll have to pardon me, I have to sit down to use the computer. And you'll also have to excuse the fact that we're on an 800 by 600 resolution, and I've just zoomed out on the browser. Hopefully nothing looks funky. I think it should work. So yeah, this is the DRMC. The first thing you see after logging into the repository is this dashboard. So I really want to quickly review what the various widgets of the dashboard do. Just along the top here is a little visual detail we added that shows the main image for the artwork that's been recently ingested. And then what you see here is our Fixity audit widget. So we're actually currently running a repository-wide Fixity check at the file level. And it's telling you that this is the name of the AIP it's currently checking. It also displays how many checks have been conducted in the last 24 hours. And the duration of the last repository-wide Fixity check that was run. And then status is okay. And then there's a little thing where you can expand to show details. And then on this recent tab, it shows you just the 5 most recently checked AIPs. And again, this is just a widget, so it's really at-a-glance stats. We have full recordings of this, which you'll see in a moment. In the event of Fixity check failures, you of course get email notifications, but you also get an indication on the dashboard here. The status turns to red, and it says failure, tells you how many, and then they show up in this fail tab. And then there's a recovery process, which we won't get into today, simply because we don't have the time. The next widget is just recent activity. So this shows you recently ingested AIPs. You get the date that it was ingested, the name of the AIP, and the artwork in the collection that it belongs to, as well as the total size of the AIP. You also get in recent activity recently downloaded digital objects. So as you can see, there's a lot of testing here. But so you get the date and time of the download, the name of the digital object that was downloaded, and there's a couple of bugs here, of course, they're blank. The user that downloaded the digital object, AIP or file, and the reason they downloaded it. So whenever a user, or really an admin, downloads an original digital object rather than an access file, it asks them to specify why they're downloading it. So it should be very, very seldom that we actually need to do that. And then the rest of these are kind of collection stats. This breaks down how many artworks are held in the repository, and then breaks it down by department. This widget displays amount of storage that is occupied by a given codec. So in our use of Archivematica, we're using media info for characterization of moving image in basically all AV formats. So So this leverages the media info codec that is reported. So as you can see, Wave PCM is occupying 4 gigabytes of our storage right now. And then we have the same exact widget for MIME type. The monthly totals based on ingest date. So this just shows you, and obviously we've only been running this test instance for 2 months, so we only have 2 points on the line chart. But it will basically chart month to month how many AIPs have been ingested. So this graph can go up or down drastically based on our activity. And then this one is based on collection date. So this basically looks at everything in the repository and then looks at our collections management system, pulls the year that the work was actually acquired, and then charts those. So we can kind of see where the repository is distributed according to the whole history of the collection. Then we have basic collection totals. So there are 36 artworks currently held in the repository. There are 179 components of the artworks. So that's a term from TMS. Artworks have components, which can mean everything from an object to a digital file to a dedicated piece of hardware. And then we have 4 supporting technologies in the system, and I'll explain that in a bit. Then we have essentially just a different rendering of the monthly totals, and these are running totals. So a way you can think of this is essentially equivalent to a trend line that you would put on a line chart in Excel, where it basically takes the number from every previous month and just adds the data from the subsequent month onto it. So you get kind of just a general trend picture for the long term. And then we did a bar chart for collection date so that you can kind of see the size of the jumps between years. The average size widget, and these are looking a little odd with the resolution, but the average size widget, what this does is it looks at the created date of the work. It totals all of the digital objects for that work, and then charts that file size, or that total aggregate file size for the artwork on its created date. So we basically, what we get here is kind of characterization of the typical size of artworks for a given year. So it's not surprising that, you know, things were smaller back here. And I think this lull here, obviously, just due to the fact that we have less things in the repository from that date. We only have 30 objects in this test instance now, where we have almost 2,000 objects to be ingested. So that this data is not exactly accurate according to our overall collections. So that's the dashboard. Next we have search and browse. So there are several different ways that you can search and browse the repository. The first level is at the artwork level. That's really just how we think about our collections at MoMA as we're an art museum. So what you see here listed are individual artworks. However, the facets that we have, they do leverage collections metadata that we're pulling in from TMS, but it also kind of mashes up digital characterization metadata. So for instance, I can say, only show me artworks that have TIFF files, and you get the results there. Or I can say, only show me artworks that have TIFF files and where's the mask here? The total size of all of the digital objects for the artworks combines to, let's say, like 10 megabytes to 500 megabytes. I don't know if there will actually be results. Yeah, so 4. But as you can see, it's a way of understanding your collection at the way that your institution thinks about it as artworks, but leveraging the sort of metadata that Archive produces. Other facets here, just to run through them, we have classification, which is something that comes from our collections management system, the curatorial department that the work belongs to, the date that the work was acquired, the date the work was created, the date materials were ingested for it, again, the total size, and then just general characterization, format, video codec, audio codec, resolution, chroma subsampling, sample rate, and bit depth. So as you can tell, we're very AV heavy because just simply the bulk of our collections are AV materials. So that's really what we chose to focus on. We can also browse at the component level. I won't really talk much about that because that only really makes sense within our MoMA ecosystem. But you get all of the same facets. You can also browse at the AIP level. You get all of the same facets, and it's also in this table that you can sort by. So I can sort AIPs based on size, the date they were ingested, by title, by classification, and it also displays the artwork that they belong to. And then lastly, you can browse at the individual file level. And when you're in search and browse, you can just click and view the file right then and there. So that's essentially a license. So next, let's look at saved searches. So let's say, I say I only want to see installations, and I only want to see installations in the media and performance art department. And I say save search.
Yes.
And now in the saved searches tab, we have that search saved. So I can click that and it returns the same results. But as you can imagine, you can generate some pretty complex, really combined, faceted searches and save those for various reporting reasons. But let's actually look at an artwork record. So let's first look at so on the artwork record, you have the main image that is pulled from our collections management database, the core metadata, which is also pulled from our collections management database. And then what you see here is called the content browser. So this is something we built to sort of facilitate the creation of enhanced metadata about time-based media artworks. All of these nodes that you see on the screen are components that were created and maintained in our collections management system. But the DRMC pulls them in, and it allows you to define relationships between these nodes. And when you ingest, an AIP is assigned a specific component. We don't ingest any AIP that doesn't already have a component in TMS. So essentially, this becomes a way of understanding kind of the process history of this artwork. So looking at this graph, I can tell that this protection master was made from this component, and that this archival master is a version of this tape, and that this exhibition copy was made from that tape, and that this, quote, digital repository file, which is just simply what was called in TMS, was made from the archival master. And then we have this file browser on the right, where you actually get to view the file. And we're actually tethered to my iPhone right now because the Wi-Fi wasn't working. So this video is not going to load, but we have one preloaded that we can show you. But I just want to show you on the right-hand side here, you get all of the characterization metadata. As I said, we added media info for, and obviously if you know Archivematica's format policy registry, you can use essentially whatever tool you want for characterization. We just chose media info because that's what we use already. And so here we have this video preloaded. This will actually play. No, probably not. But in any case, to show you one more feature of the digital object viewer, one critical thing that we often do in media conservation is sort of compare two files. So we have this file, we have that file. They're actually the same content, but we have these two files. Why? There must be something different about them. So you want to compare the characterization. So in order to do that, essentially you go into this thumbnail view and you hold down Shift, and you can multi-select up to 3 files, and you click Compare, and you get the characterization side by side. And these don't have very verbose characterization, but as you can imagine with those MOB files, it can be extremely useful. So because it's so structured, you can kind of glance from side to side and really get a sense like, oh, the chromosome sampling is different on this file, or it's a different codec. These are all things, of course, that are trivial to do with just command line-based tools, but the idea is that these are things that we've stored in the repository, and maybe we're only accessing it 25 years later, so it's good to have that stuff at your fingertips. Yeah, we're really running short on time. Should we keep going? Or should we yeah, maybe we should ask Would you all rather see more of the system, or would you rather see information about our TDR assessment? Show of hands. System. TDR assessment. Wow, system it is. Okay, great. So reports. I'm glad you said that, because the reports are really cool. So it's just what I'm doing here. We have high-level ingest report. All reports you can run either for all time or for a specified date range. And what the date range is leveraging depends on what the report is, which one is specific. So high-level ingest report, like I said, it's high-level. It just tells you within the reporting period how many new artworks were ingested with material for the very, very first time. So we just ingested the file for this artwork and we previously had nothing for it. Versus artworks where we already had something, but we added something to it now. And then the aggregate number, number of AIPs ingested, total amount of digital content ingested. So that's high-level ingest. The granular ingest report looks like this. So it has two tabs where the first tab is by user and the other is by curatorial department. So by user, you get the name of the AIP, classification of the AIP, the universally unique identifier, what artwork it belongs to. But the reason it says by user is because, as you can see, this is all for my user. So if you scroll down, you basically get the total for that specific user. So if you have multiple people ingesting, this is a way of reporting like who's using the system more. And then it's the same by department. So if you want to see like, is our architecture and design department ingesting more than our media performance art department, for instance, you get the same totals there. And I'll skip over the download report. It's essentially the same as ingest, just obviously the inverse. Amount downloaded is essentially the same. The fixed report looks like this. So collection reference is essentially a repository-wide fixed check. So each of these, you'll see this scroll down. Yeah, so I guess we only have one repository-wide fixed check in the system right now. We figured it out before. But it tells you every AIP that it checked and the outcome, how long it took to check it, and so on. But I should mention also that if you don't save this report, it's just in the browser. So if you want to access this later, you can save, or you can also just download the CSV. And video characteristics report. This is a very, very, very useful one for us. So this is a way of just getting across the entire repository for things that have a MIME type that falls within an AV category. It gives you the file name, the artwork that it belongs to, its total size, and then essentially the characterization of the file with each characteristic in its own field. So this gives you a way of, if we know that we have our certain standard for, let's say, chroma subsampling, you can just kind of like visually scan through there, or you could download the CSV and graph this data, essentially do whatever you want with it. And again, that can be run for the whole history of the repository or for a specific period of time.
Are you extracting that metadata at the time of ingest then?
Yeah, so I didn't really explain that, but so our ecosystem is really Archivematica in this system. So when things go through Archivematica, of course, it produces very verbose characterization metadata, checksums, all of that good stuff. So this is really the system for leveraging all of that. When it gets sort of indexed by this system, it becomes, that's where this metadata actually becomes useful, because of course, like somebody was saying before, XML is the answer to all of our problems and none of our problems. It's the answer to our problems in the sense that it's a good long-term format that's self-describing, but it's useless. So we can't do anything with this. So we index it. So that's report management. So those relationships we're seeing in the context browser, that's a taxonomy that we control. Only admins can change it, of course. Yeah, and we're at time. Yeah, sorry. I wish we had time for questions.